Hello students, let's discuss the NEET 2023 paper. In this paper, what is most observed is majority questions which were there were all from the NCERT part. Let's see what the questions are and what exactly it was. The first one, it says the statements are given below. A reaction can have zero order activation energy. That is possible because if there is zero activation energy, meaning as per the equation what we have, if you observe, K is equal to AE raised to minus EA by RT. So if the activation is zero, K is equal to A, which means whatever collisions are happening between the molecules, they all lead to a perfect chemical reaction. That's one. So the first one over there is correct. And the second is what we have is the definition of an activation energy. So here in this question, if you observe, it's asking over there among the two statements they have given. Now, what is the correct answer over here? It's the first one basically. Why? Assertion and reason both are true, but reason is not the correct explanation because the second one is basically the definition of activation energy. Okay. Look at the second one. You have a ketone reacting with HCN to form a cyanohydrin, which with conc H2SO4. So here they're asking what is C. If you observe carefully, here the answer is going to be the third one. What does that mean? This cyanohydrin, what we have over here, this cyanohydrin with conc H2SO4 will undergo one acid hydrolysis as well as it will undergo dehydration to give basically over there and a double bond over there. Look at this. 52. The ketone with HCN cyanohydrin, conc H2SO4, it will give an acid, but also because of conc H2SO4, there will be dehydration. Then the next one, the third one, the compound is, now this compound, if you see carefully, this is nothing but allylic. What is the definition of allylic? Halogen atom is directly attached to a carbon, which is a part of C, which is then directly attached to a CC double bond. So halogen directly attached over there to a sp3 hybrid carbon. So the nature of this carbon is sp3 and it is again directly attached to a CC double bond. So that's an allylic group what we have. So 53, if you observe, then that's nothing but what we have as allylic. That's the part. Then the next one we have intermolecular forces. Now the intermolecular forces of attraction between the two molecules. It can be dipole-dipole forces. It can be dipole-induced. It can be hydrogen bonding. It can be dispersion forces. It cannot be covalent bonding because covalent bonding is intramolecular between two atoms within a molecule. So 54th one, if you see here, then the correct option, what makes sense over there is nothing but the B option over there. There is a second option. That is A, B, C, E are correct. So that's the 54th one, what we have. Covalent bonding is intramolecular. Then the next one we have, which of the following reaction will not give primary amine as a product? Cyanides on reduction with lithium aluminum hydride followed by acid hydrolysis will give a primary amine. B is the one which will not give. Why? Because it's isocyanide. Isocyanides on reduction gives 2-degree amines. That is the NH group, imino group. So 55, that answer over is the second one over there. Okay. Then next one, the 56th one, again assertion and reason over there. What it says, metallic sodium dissolves in liquid ammonia forming a deep blue solution which is paramagnetic. This is a correct statement, that is true. And the deep blue solution, it says, is due to the formation of amide. False. Is due to the formation of the ammoniated electron. All right, it's the ammoniated electron. So it's false over there. So here we have the second one, that is the statement A is true, but the reason is false. So 56 is 2. Then 57th one, it says, for a reaction K, A raised to 2 into B, when the concentration of A is tripled, keeping B constant, initial rate would be. Now, if you keep B constant and if you triple A, very simple, A will be 3 raised to 2 and B will be a constant only as it is, right? So 3 ka square, that's 9. So it will, the rate of reaction will increase by a factor of 9 over there. So 57 is 2. All right. Next one, 58. Taking stability factor, which of the following represents correct relationship over here? Please read the lines properly here. So the correct relationship is 3. That is over there, thallium iodide will be more stable than TiI3. Reason, here it is in +1 state, here it is in +3 state. As one goes down the group, stability of +1 oxidation state increases and that of +3 decreases due to inert pair effect. So 58 will be 3. All right. Next one, 59th one. Among the following options, which of the following molecules or ions act as Lewis acid? Lewis acid means lone pair acceptors. Lone pair acceptor, there will be only one option, BF3, because boron has a vacant 2pz orbital to accept a lone pair of electron. So that's one. Okay. Then 60th, number of sigma and pi bonds and lone pair in pyridine. Now pyridine, we all know the formula, C5H5N. So here if you see the bonds, here the correct answer will be the second one. It has got 11 sigma bonds. Look at the structure carefully. 11 sigma, 3 pi and 1 lone pair. C5H5N. Heterocyclic aromatic compound. Then 61, it says the correct order of the molecular orbitals of N2 will be. Here the answer will be the last one because sigma 2pz is of higher energy than the pi 2px and pi 2py molecular orbitals. So 61 is the last one. Fourth one. Then consider the following part. 3-methyl-butan-2-ol with HBr will give what product? This is a solid example from the NCERT what they have asked. It's basically hydride shift, where we convert a 2-degree carbocation into a 3-degree carbocation, which is more stable. So here the answer, if you observe, will be nothing but over here. 1 minute. The correct answer is not printed, I suppose. It's 1, 2, 3. Oh, sorry, I think it's gone on this page. Yeah, the fourth one. Here it is. So this is the answer. I'll show you what the mechanism is. See here. Look at the 62 ka mechanism carefully, everybody. What it says, first HBr, it forms a 2-degree carbocation. Then because of hydride shift, it becomes a stable 3-degree carbocation. And then the Br will attack to give you a 3-degree alkyl halide. So 62 is the fourth one. Then 63rd one, what it says, again, the statements are given below. Delta G is minus NF E0 of the cell. Value of delta G depends on N. Correct. Because delta G is an extensive property. So it depends upon it. So first statement is true. In the second one, what it's trying to say over here, E of the cell is intensive property and delta G is extensive. This is also true. But in the light, what is the part over there? Assertion and reasons are right. But reason is not the correct explanation, because in reason, it should have been only delta G is extensive. Nothing to do with E of the cell. All right. So that's why it says, okay, assertion and reason both are true, but reason is not the correct explanation of A over here. So here the answer will be the first one. So 63 is the first one. Then the next one we have, that is 64th one. What it says, homoleptic complexes having only one type of ligand. This also is a very easy one. It's the fourth one. Potassium trioxalato aluminate. Look at this structure. That's K3Al C2O4, the whole thrice. C2O4 is nothing but oxalato ion, 2 hydrogen atoms short from oxalic acid. That's a bidentate ligand. So that's one for 64. Then 65, again, the two statements are given below. Look at that. Okay, choose the correct answer. It says over here, helium is used to dilute oxygen it's not dividing, it's diving. In diving apparatus, that's a correct statement. And helium is highly soluble in water over there. No, it's not highly soluble. It has, in fact, low solubility in blood. All right. That's why it prevents nitrogen from entering the bloodstreams. So here, if you see, the answer will be the second one, that the assertion is true, but the reason is false. So look at this, the 65th one. Yeah, it has low solubility. 66th, a very easy one. You have two ketonic groups, zinc amalgam and conc HCl. We all know. What is zinc amalgam and conc HCl? Clemenson's reduction. So Clemenson's reduction, the rule is simple. The carbonyl group is reduced to methylene group. C double bond O becomes CH2. So 66th one, if you observe, here is nothing but what we have as, yeah, there we go. The answer will be D, Delhi. That is Clemenson's reduction. Both places, the carbonyl group becomes a methylene group. C double bond O becomes CH2. So look at that. 66th one, Clemenson's reduction. Carbonyl to methylene. Next one, 67th one. Benzene diazonium chloride first with cuprous bromide in presence of HBr. So you have first product formed, bromobenzene. Bromobenzene with magnesium and dry ether. That's going to be phenyl magnesium bromide, Grignard's reagent. And third part, you add water. Grignard's reagent reacts with any source of proton and gets decomposed to its respective hydrocarbon. So if I have phenyl magnesium bromide decomposing with water, it will form benzene. So that is 67 is the first one. Look at the reaction, please. That's 67. Have a look at it. Diazonium salt first giving bromobenzene, then giving phenyl magnesium bromide, which with water giving us benzene. That's 67. Then 68 one. What it says again? Okay. A unit formed by the attachment of base to a 1' position in sugar is called as over there nothing but a nucleoside. Yes, this is a true statement. And when nucleoside is attached to phosphorus acid, this is basically the false statement. Why false? It's not phosphorus acid. It is phosphoric acid. So here in this category, it's the second one. Statement one is true, but the second one is false. So 68, that's 2. Not phosphorus acid, phosphoric acid. Then the next one, which among the following molecules on polymerization produces neoprene? Neoprene is neoprene rubber. So that compound is nothing but what we can have is which molecules will polymerize. It will be the first one. Okay. And what is this? This compound is nothing but what we have as 2-chloro-1,3 butadiene, which polymerizes to give us neoprene rubber. That's one part. Then, so that's 69. Then 70th, the relationship between n, permissible values of magnetic quantum number for a given value of azimuthal quantum number. People, from azimuthal quantum number, we can calculate the magnetic quantum number, which was 2L plus 1. Here they have asked exactly ulta of it. How is the other part related? Then that answer is going to be nothing but what we have as the D option, the last one. LS will be magnetic quantum number minus 1 divided by 2. I'll explain you with an example. Have a look at it. Look at the 70th one. The values of n and n are derived from L, and the value of L are derived from n. So I've given for L, basically we have the 4 subshells, SPDF 0, 1, 2, 3. So if you take an example, if L is 2, that's your D subshell. We all know D subshell will have 5 orbitals, dxy, yz, xz, dx square minus y square, and dz square. So if I put it into the formula, the last one, that is nm minus 1 by 2. So there'll be 5 orbitals minus 1 by 2. So basically L will be 2. So it's basically calculating the other way around. So 70th, that's the last one. Then 71, what it says, the question is the stability of cupric is more than cuprous in aqueous solution. The word has given the answer. It's because of its hydration enthalpy. Then some tranquilizers given below over there. What it says, which of the following belongs to barbiturates? Barbiturates is nothing but what we have as veronal. Look at this. It's a class, basically it's a line what we have. Veronal, amityl, nembutyl, luminal, and seconal. All these are derivatives of barbituric acids. That's one. So 72, that's the third one. Then 73, the element expected to form a largest ion. Now people, we know, higher the charge on the cation, smaller the size, and higher the charge on the anion, larger the size. So it's nitrogen, which can readily form a nitride ion. So nitride ion will have the configuration of neon. That's the nearest noble gas. And as higher is the charge on the anion, the size will be larger. So 73 is 2. Then 74, not correct. These are all the lines picked up. What it says, hydrogen is used to reduce over there nothing but what we have as heavy metal oxides to metals. So, it's used to reduce heavy metal oxides to metals over there. Yeah, now what it says over here, which of the following is not correct. Okay, so here in this category, first one is true. Then heavy water is used to study reaction mechanism. Yes, that's also true. Hydrogen is used to make saturated fats from oils. Yes, that's the process of hydrogenation, what we know. Then the hydrogen bond dissociation enthalpy is lowest as compared to a single bond. This is a false statement. It's given, it's the one which has the highest enthalpy, not the lowest. And last, hydrogen reduces oxides of metals that are more active than hydrogen, not more active. It should be less active. So your D and E are nothing but the false statement. So that's over there, nothing but option 2. That's your 74. Okay, have a look at this. Then, right? Next one, 75. What it says, compound is formed by two elements A and B. A occupies the CCP lattice. CCP means A ka contribution is 4. FCC, 8 into 1 by 8 plus half into 6. So that's 4. And B occupies, and sorry, that's B, sorry. I'm so sorry. It says that's for B. B occupies, so that's the part for B. And then it says A occupies over there 1/3. Now, if B is 4, that's the what we call number of atoms in FCC. Number of octahedral voids is the same as 4. Tetrahedral voids is double, 2 into 4. That's 8. And it occupies 1/3. So A ka contribution will be 8 by 3. So you have A 8 by 3 and B 4. So basically A 8, B 12. Multiples of 4. So that's going to be A2, B3. And they want the summation of X and Y. So that will come as 5. So that option is fourth one, which is 5. So 75 is 4. Then 76, which of the following statement is correct? What it says over here, all enzymes that utilize ATP in phosphate transfer requires calcium as a cofactor, not calcium. It's magnesium as a cofactor. So first one is false. The bone in the human body is an inert and unchanging substance. It's also false. It's not inert. Regular, there is deposition over there of calcium over there in the bone. So it's not inert. And magnesium plays a role in neuromuscular function over there. So here, if you observe what it's trying to say, this third statement is also false. It's not magnesium, it's calcium, which plays a role in the neuromuscular function. And the last one, daily requirement of magnesium, calcium, that's the correct one. So that's the true statement, what we have. Okay, so 76th one. This was the working of that previous question, 75. Okay, and 76th one, that's this one. Okay. Then 77th, what it says, among the following species that not having 8 electrons, people, ammonia will have 8, aluminum chloride will have 6, BeCl2 will have 4, CCl4 will have 8, and PCl5 will have 10. So not having are basically 3 species. So it's 4. So 77. There you are. Just count the electrons in the outermost shell. So nitrogen is 2, 5. So 5 plus hydrogen 1 into 3. Like that. Aluminium, beryllium, dichloride, carbon tetrachloride, and PCl5. So 3 species don't have 8 electrons. Then 78. Weight of 2 moles of a compound which is obtained by heating sodium ethanoate with sodium hydroxide. This is decarboxylation. Decarboxylation of sodium salts of fatty acid gives an alkane with one carbon less. So sodium ethanoate will give us methane. 1 mole methane, molar mass is 16 grams. You want the weight of 2 moles. So 16 into 2, that's going to be 38 grams. So 78.1, there you are. Clear? Then 79th one, select the correct one. Atoms of all elements are made up of two fundamental particles. That's false. It's made up of protons, neutrons, and electrons. So not two, it's three. Mass of electron is 9.1 into 10 raised to minus 31 kg. That's a true statement. All isotopes of an element should have the same chemical properties. Yes, as atomic number is same, they will have the same chemical properties. Protons and electrons are collectively called nucleons. False. It's not protons and electrons. It's protons and neutrons. And last one, Dalton's theory. Is this clear? If you observe, regarded the atom as the ultimate particle of matter there. Now what they are saying, select over there nothing but the what I can call the correct ones. So the last one is also true. So here if you observe, you have over there nothing but B, C, and E are the true ones. So that's basically your third statement. Then next one, 80th, which of the following is an example of heterogeneous catalysis? Heterogeneous catalysis, the reactants and the catalyst are not in the same phase. That's only one option what we have. That's nothing but over there, the third one, that's the combination of dinitrogen and hydrogen, dihydrogen to give you ammonia. That's Haber's process. So look at this, 79 and 80. All right. In 80th, the 1, 2, and 4, all are homogeneous catalysis, means the reactant and the catalyst are in the same phase. Then 81, which option represents Boyle's law? That's nothing but if you observe, that's option A, because pressure is inversely proportional to volume. So pressure against 1 by V will be a straight line passing from the origin. That's option 1. Option 4 could have been correct if these options were ulta, like T1 greater than T2 greater than T3. Then the fourth one also is nothing but what we have as the Boyle's law. Pressure increases, then the volume will decrease. But the temperature should have been T1 greater than T2 greater than T3. So 81st is the first one. Then next we have the 82nd one. What it says, again, match the columns. Coke. Coke is basically used as a reducing agent. So that's A. Diamond, that's sp3 hybridized. What we have as B. Then fullerene, that's basically nothing but a cage-like molecule, soccer ball, what we call. So that's C. And graphite is used as nothing but a dry lubricant. So that's over there, nothing but option 2 over there. First one is nothing but 3. And then second one is first one. Fourth is then the C is the fourth one. And the last one, graphite, is nothing but 2. Then people, this very direct question of mole concept, right option for the mass of CO2 produced by heating 20 grams of 20% limestone. Then that's going to be nothing but A, 1.76. Look at this. A very direct one. As per the reaction, 1 mole of CaCO3 is 100 grams, giving me 1 mole of methane, which is 44 grams. So they are saying 20 grams will give how much? So that's 8.8. And they are saying it's only 20% pure. So 8 grams ka 20%. That is 1.76 grams. That's one. Then 84th one, Lasagne's test. It says when both nitrogen and sulfur are present, it gives blood red color. So that blood red color is because of FeSCN2+. That is this compound. All right. Ferric plus over there, nothing but thiocyanate. So that's 84. 85th is a dumb question to us. It's very direct. Conductivity of a centimolar set. Conductivity is kappa and resistance is R. They are asking cell constant. Cell constant is conductivity into resistance. So just multiply directly. That will be nothing but option B. So that's 85. All right. Then next we have, that's the 86th one. This is the good question. Have a look at it. Among the following, which will be most readily dehydrated? Now, most readily dehydrated will be the third one. Now, what is the concept of it getting dehydrated? Dehydrated in acidic condition, meaning intermediate carbocation has to be formed and the carbocation should be more stable. So the alkyl groups, so you have two things, stability of carbocation and second, the plus effect. So option A and B to are out because with two OH groups over there present, that's not the one. So it's either C or D. Now out of the third and the fourth one, why the third one preferred? Because there's a gap between the NO2 and the OH. So more the gap between the NO2 and the OH, there's alkyl groups which will show plus effect, which will enhance the stability of the intermediate carbocation. In the last one, the branching is more, due to which we say the distance between the OH and the NO2 is also less. Hence, the stability of the intermediate carbocation will also be less because NO2 shows minus effect. So plus effect and resonance stabilization are the two answers to explain the one, the stability of the intermediate carbocation formed after dehydration. So 86 is the third one. That's one. Then people 87th over there is nothing but the first one, which is with respect to the structures, what are there. I'll just show you this. Have a look at it. They have given the four: peroxo disulfuric acid, sulfuric, pyrosulfuric, and sulfurous acid. So look at this. For the previous one, the resonance stabilization and the plus effect. Now I've given all the four. Have a look at it carefully. You will understand. Peroxo disulfuric acid. How many bonds? Sulfuric acid, pyrosulfuric acid, and last is sulfurous acid. Clear? Then 88 one, what it says. Okay, acetaldehyde first on reduction. So acetaldehyde on reduction will give ethanol. Ethanol over there with H2SO4, intramolecular dehydration, B will be ethene. Ethene with HBr, C will be ethyl bromide. And ethyl bromide with bromobenzene, that's Wurtz-Fittig reaction. It will give me ethyl benzene. So that's going to be nothing but the last one. Look at this reaction, everybody. Look at this, how it is formed. Acetaldehyde, reduction, ethanol, intramolecular dehydration, ethene, hydrohalogenation, ethyl bromide, and then with alkyl halide and aryl halide with sodium, that's Wurtz-Fittig, ethyl benzene. That's 88. Then 89, which complex is most stable? This is also a good question. Easy to gauge. The second one, why? Because you have ene over here. Ene is basically ethylene diamine. That's over there, nothing but a bidentate ligand over there. So when you have bidentate ligands, these are basically the chelating ligands. So they will enhance the stability of the complex because there are two factors. One, more stronger field ligand will enhance the stability, and second is the charge by radius ratio. So here all are of cobalt, so the charge by radius ratio remains the same. So all we have to see is which is a strong field ligand. So ene being a strong field ligand and a bidentate ligand which enhances chelation, we will say the complex formed would be most stable. So 89 is 2. Then 90th, which is the correct option? This is a very direct question asked, which is the first one. Delta H is delta U plus delta nRT, where delta N is gaseous products minus gaseous reactants. It's basically the heat of reaction at constant pressure and heat of reaction at constant volume ka expression. So 90th is the first one. Then, so 89 and 90th. All right. Now, next one, last 10 questions. 91. Look at that. You have benzyl phenyl ether when heated with HI. This is a good question. Here, the very direct one to catch, it's going to be the second option. Normally with HI, when you heat it, lower group forms the iodide, higher forms the alcohol. But only in two cases, you have the higher forming the iodide. One is if it is a 3-degree alkyl group. Here in this case, it's a benzyl group. If you observe, this group is benzyl. And benzyl and allyl, they favor SN1 mechanism. So due to SN1 mechanism, benzyl will form the iodide, and the other will form phenol. So 91 is 2. Then 92, the nutrient deficient water bodies leads to over there nothing but what it call as eutrophication. This is a false statement. In fact, it's not deficient over there. Over there, it is basically the nutrient rich water bodies. So it should be nutrient rich. And the second statement, eutrophication leads to decrease in the levels of oxygen. Yes, that's because of there are more minerals which are added. So the level of oxygen will definitely decrease over there. So second is a true statement. So here in this category, it is the third one. Statement 1 is incorrect, but 2 is correct. Then 93, they have given the species. We have to identify which of the following obeys Huckel's rule. Huckel's rule, 4n plus 2 pi electrons. So 1, for any compound to be aromatic, it should have a, basically all molecules should lie on the same plane. Hybridized state of carbon should be sp2, and all should satisfy Huckel's formula that should have 4n plus 2 pi electrons. So here, let's see out of the 7 compounds, how many of them, they satisfy. Have a look at it, please. Look at this. First one, that's nothing but anthracene, that satisfies. Second one, what we have, that also satisfies because the lone pair is considered to explain aromatic character. Third one doesn't. Fourth one doesn't. Fifth one does because there's only one. All carbon atoms are sp2 in the fifth one. So it satisfies with 2 electrons. Sixth one does not because there are 8 pi electrons. And the seventh one over there is anthracene. Sorry, the first one was naphthalene, which satisfies. And the last one, seventh one, is anthracene. That also satisfies. So the seventh one does. The fifth one does. First one does. Yes. So you have total 4 compounds satisfying over there. The first one, that's anthracene. Then the second one. Then we have the fifth one. And then the seventh one. Yeah. So here, basically, when we are talking, it's going to be 4 compounds satisfying. Then next one, identify the major product. Now this aldehyde with AgNH3 twice plus 3 over chance is nothing but Tollens reagent. So with Tollens reagent, the aldehyde gets oxidized to its silver salt of carboxylic acid, which in an aqueous medium ionizes to form its carboxylate anion, and silver and the Tollens reagent gets reduced to give you silver mirror. So here the correct option is going to be the second one. Have a look at this. Look at this reaction for 94. Aldehyde with Tollens reagent, it gets aldehydes oxidized to their carboxylate anion. Then 95, fraction of H center. H center fraction is 1/4. All right, that's one. Then 96th one. Now this is basically redox balancing in an acidic medium where chromium, 2 chromium atoms is plus 12. Here it becomes plus 6. So there is gain of 6 electrons. And sulfite to sulfate, plus 4 becomes plus 6. So it's basically loss of 2 electrons. So you multiply to balance the electrons or cancel the electrons on both the sides. The sulfide ions is basically what we balance 3 times on both the sides. And the chromium remains as it is. Now, if you observe here, the more correct option which we'll set over here is nothing but the D1. That's 1, 3, and 8. Because then you balance the oxygen and put that many water. Now here, if you observe, you have 9 plus 7, 16 oxygen on the left-hand side. And on the right-hand side, you already have 12 oxygen. So to balance, you'll be adding over here 4 water. All right. So if you add 4 water over there, that's going to be 8H plus. And this will be nothing but, so 8/2. So that will be 4 water. That's the balancing, 1, 3, and 8. That's 96. Then 97th one, reaction that does not take place. This is basically from the diagram from metallurgy between 900 to 1500 Kelvin. That will be D. First 3 will will be formed over there. The last one is not formed. So 97 is 4th. Then 98, which of the following statements are incorrect? First one, all metal transition except scandium form MO, which are ionic. That's true because scandium is more stable in +3. And here MO means metal is in +2. Highest oxidation state corresponds to the group number attained by Sc2O3 and Mn2O7. Yes, that is also a true statement. And basic character increases from V2O3 to V2O4 to V2O5. No, this is a false statement. Basic character, in fact, over there will not increase, it will decrease. Then V2O4 dissolves in acids to form VO4 salts. This is also false. It basically forms VO2 plus salts, not VO4 salts. And CrO4 is basic, but Cr2O3 is amphoteric. Yes, this is also a true statement. So they're asking how many of them are incorrect. So incorrect is basically C and D, which is option 2 over there. Okay. So that's 98. 99 people, a direct equilibrium question, which is nothing but the second option. And the last one, 101, that's nothing but pumice stone is solid salt. Have a look at this. I'm just showing you the working for the last part over there. One is this redox reaction, what you balance. And then the last equilibrium question. Have a look at it. First, calculate Kc, which comes to be 10, and then direct formula. Delta G naught is minus 2.303 RT log of Kc. So that's minus 1381.80 cals. And pumice stone, solid salt, that's a gas in solid type of a colloid. All right. Thank you.